Alright, should be another DraftScience video presentation. I'll do some comments, then we'll get back to the subject of the fact that physics has two equations which you can use to describe how much energy something has. And so much energy something has is a real thing. I mean, it's a real amount of energy, and they should be able to tell you how much energy something has in some sort of comparison. Now, the standard rule is this joule amount, and the joule basically means you take, a kilogram had 2 pounds, right? Yeah, that's too much. Well, 100 grams, so 100 grams. Well, anyway, and you drop it 1 meter. When it hits the ground, there, that's your kilogram per 1 meter of distance, and so drop it and it hits that amount of, that's about a joule. Right there is a joule of energy. And we should be able to say, when we look at something in some event, okay, how many of this does that seem to equal? That's pretty much what you're saying. How many of that does it equal? Sorry about that. But anyway, and they have two different equations, and the equations get completely different answers. I mean, just way off. One says 100, the other will say 300, that kind of crap. So way off. And the question is who thinks that makes sense? Who thinks that's good physics, is to have these two equations, and even have a preference for one that sort of creates an awful lot of variation. So it's a legitimate question, and so this commenter says, I'm out. Okay, so you don't like the subject, what? I said out of momentum or kinetic energy because it's just so useless, as commentary. I mean, there's a real question, you don't want to answer it, fine, go away then, I'll help you go away. But I mean, it's just too stupid. It's a real subject. I mean, you can print it on a subject, but it's a pretty real subject. It's a real question, and it should have a real answer. And you people should pick a side somewhere and defend it, not this nonsense. Alright, and then Jerry, who emails, I suppose, so this is Jerry 3, I assume it's the same guy. The Quora thing is essentially the whole video example of what I was criticizing you in the comment a few weeks ago. I don't think so. So you could have posted that elucidation that you provided. I mean, the only thing I'm conceding here is that I was wrong to say when you throw something up at twice the speed, it goes twice as high, and instead it goes 4 times as high. And as I point out, the same rule applies to when you're dropping something. So, I mean, I'll illustrate this because this gets right to the point of why I think you people defending this stupid equation, the kinetic energy equation, as having any real meaning at all as good physics. Because the argument is okay, I want to double something's velocity. So this hits with, let's just say 10. If I want to hit with 20 power, okay, I have to go 4 times higher. 3 times the initial height to get to 20. So just to double my velocity, okay, I have to sit there and go way up here in gravity. Now the truth is, this will be 1 second and this will be 2 seconds. So this one will fall in this distance in 1 second. Okay, 1 second, and this will only be 2 seconds. So I would make the simple rational argument, okay, that gravity's throwing force in at the same rate. So in 1 second, you get a certain amount of gravity. If this was a bucket, you're putting a certain amount into the bucket per second. And it just doesn't matter how fast or whatever the bucket's doing, means absolutely nothing to gravity. Gravity's going to put, okay, the 10 grains of sand in per second. 10 grains into this bucket, 10 grains per second into this bucket. Alright, so when this hits at 20, alright, it's because it has 20, okay, grains of sand. and this one hits at 10, well, it collected 10. Now this one collected 10 because it moved slower, right? It had to start accelerating and move, and this one has to start accelerating and move. But once it started moving, it moved really fast. So it covered this much distance in 1 second. But in that 1 second, there was only 10 grains put inside the bucket. So so my formula, the formula I'm defending, okay, the Galilean kind of perception, is just mv squared. Mv equals energy. And that's it. Okay, so if we're just going to say joules or something, so we just say, what's your mass, what's your velocity, and that'll tell us how many, hand claps worth of energy you have. How many hand claps of energy it would take to lift you to that position. Now their formula, so let's just say this was a number like 100. All right, that was the number. Okay, for this object's how many hand claps it has in it. Now if I use their formula, okay, 1/2 mv squared, I get 300. Now these numbers really aren't even close, right? There's no way you say, oh, it's approximately equal, or I can put wavy line equal. No, they're not. They're not equal. Those numbers are not equal. They're not even close to being equal. They're not even close to the same. And that's a real problem. It's not a fake problem. It's not a phony problem. It's not just because some asshole on the internet brought it up problem. This is really doesn't seem like very exact physics. And so I'm defending why, this is the arguments I've been making, is I'm defending that whatever distance something travels is not part of, what kind of spring we're using to test is, yes, of course you can say, hey, look, it's 4 times the distance, so of course it's 4 times as much energy. Well, we know though that it's doing that in gravity, and the rules of gravity are, no, I only dumped 20 grains of gravity into it. There's only the 2 seconds. Okay, it doesn't matter how fast it's moving in the gravity. It matters, I'm telling you, relativistically, but it doesn't matter. It's not relativistically. It matters in the same way that Einstein thought it mattered. It does matter which way you're going in a force, but not for the same reasons Einstein says so. But anyway, it doesn't matter for the purpose of this example. Whether you're moving or you're not moving or whatever you're doing, you're just collecting energy effectively. You're collecting momentum, and your momentum is the real amount of energy. The fake part about how far you move, that doesn't mean anything. It doesn't have anything to do with how much energy you have, as this proves. As you have to go 4 times higher to double this momentum. All right. So my simple argument is, it's clearly in the gravity. You're only collecting gravity at a certain rate. Time is the important feature about how fast you can collect gravity, and that's why the momentum formula is more likely to be the right formula. Yeah. So, yeah, Jerry, I don't, fine, I let you post your comment, you had your little fun, but I really don't think 3 weeks ago you were telling me, well, you have to throw stuff 4 times as hard in gravity. And again, okay, that's one little tiny piece of this whole argument. So don't pretend I have conceded anything on the substance of the argument, which is about these 2 equations and whether your energy can be defined by this silly 1/2 mv squared formula. So none of that's changed. Alright, Zohar. Hey, how about about the recent kinetic energy versus momentum thing? I don't think you're going to talk about that. Okay, I've thought about it a bit, and the position function of an object's height. So again, you're going right back to okay, I'm only going to talk about it in terms of gravity. It's not about gravity. This equation is used for everything. Okay, this isn't just a gravity formula. It's an everything formula. Whether you're a car, whether you're this, your train, a bus, doesn't matter what you're doing, they use this formula. So you're missing the point. All right, and then he provides the gravity formula. So, I mean, it's already a conceded point. So why would I re-argue a conceded point? Okay, basically you can graph this in demos. Yes, we've gotten it, the whole thing. It's more than twice, he says. No, we already know it's not just more than twice. Okay, it's 4 times. Okay, we already know that. We know the first part of the motion is very, very little distance you cover when you're first accelerating. So in the first second of falling, okay, you only travel 4.8 meters. You don't get very far. All right, but it was a full second of getting loaded with sand in your bucket, and then the second you go 4 times further. Whatever. Okay, I'm willing to discuss. Yeah, well, just make a video. You know how to make videos. If you have a point to make, or an argument, or a counter argument, then just make them. I don't see any point in getting into a conversation, especially when it's just going to be some semantics argument. You know, forget it. You know, re-saying what I have to say with another person doesn't make much sense. So unless you're making a real argument, you know, it's just not worth the time. I don't need to re-say what I've already said. You know, I don't think so. I think the last few videos have been pretty explicit in what the argument is, and if somebody can't catch on, you know, they're just not capable of having the conversation, frankly. It's pretty clear. I've isolated, there's 2 formulas. There's 2 ways to look at what energy is. One formula has this bizarre notion that mass is half important and velocity is everything. So how fast you're going matters how much energy you have. It doesn't have anything to do with how heavy you are. And, you know, I think that's absolute garbage. It's clear your mass is just as important as your velocity is. If you're an asteroid, if you're anything going on in the universe, if you're the Earth and the Moon and you're doing gravity, it matters. Mass and velocity are equally important constituents to you, what's called your energy. And that's just a fact. Alright, so there was another comment by the YouTube guy, or whatever his name was. YouTube user or some kind of stupid name. So he's, you know, I blocked him because this is just redundantly, every comment he has to start with a false premise. And it's just like, I don't have to accept that. You know, it's either an overt lie or just some sort of, you know, shit remark that doesn't, you know, that's not an argument. Okay, as expected, you diverted the subject. No, I didn't. The whole video is well titled. It's about momentum and kinetic energy. It's titled that. That's what I talked about in 99% of the video. So again, it's just a huge, giant fucking lie. Alright. From the subject of my comment to talk about the double slit and other matters. I talked about the context that these are the 3 experiments, okay? I mean, we had 3 pieces of evidence for against, so the one against quantum mechanics is the double slit experiment, because it just undoes. It's their cornerstone experiment, and if it can be better explained as a particle theory, quantum mechanics is over. Okay, it's done, it's cooked, it's, you know, garbage. Alright, entanglement, all that crap goes away as soon as you prove that photons are particles. Alright, real particles, not wavicles, not wave functions. You know, all that de Broglie bullshit goes away, all the Dirac nonsense goes away. Alright, and then there's the gravity question, the fact that you can explain gravity as just an absorption of energy, that any time matter moves, matter moves because it's collecting energy. And it has it. And then that sort of relates to this argument about what the fuck energy is, and is it real? Do things really possess it? And that's my argument. They actually do collect it. They actually do have it. And all this relativity shit goes out the window because, yeah, there's something that's really moving and something else is really not moving. And those are real facts. And you can't play this game that, oh, I can pretend one of them's doing something and one of them's doing something else, because there's an actual fact that one's carrying the energy and it matters which one is. Because they're real vectors of momentum and they really have to go somewhere. Alright, so that was all I did. It's in the video. I've made a little bit of a point referencing that fact. So a little bit of context, that's all there was. The rest of the video is entirely on the subject of which one of these equations has any integrity, getting to the truth about what energy is and how much of it there can be. whether energy is about what it looks like or is it what it is like. Okay. All right. You can make all sorts of claims, but until you can provide the experiments. So again, this is never about the experiments. It's about the interpretation of the experiments. So just, again, this is just such a moronic lie. All right. Anybody who has any kind of familiarity with the two-slit experiments knows the basic features. Okay. In the two-slit experiment, you have the envelope pattern. You can adjust the slit width and the impediment width and change the pattern and make it look different ways. And the question is, what's causing the effect? The question isn't any other question. All right. We all have the same evidence. It's just that sometimes the people on your side cite evidence that doesn't exist, like detector experiments that never took place, and then they claim that a place that was light gets dark, but they have no evidence of that one either. They say lots of stuff about what the evidence is, but they really don't have any of this evidence. Just like the Eddington experiment, we proved it, but we never in 100 years did the experiment with better technology. Never. Didn't even try it with better technology. Okay, so come on. I mean, you're just such a lying piece of shit. I mean, how can I possibly have a conversation with somebody who premises things like this? Like, we proved it, we did it, you wouldn't have light bulbs if it wasn't for quantum mechanics, blah, blah, blah. Bull fucking shit, and you know it. Alright. Can you provide experiments and math? Well, again, I have provided the math in the double slit experiment, but frankly, you think physics is math. I don't think so. Drawings are math. Okay, explanations are math. I mean, drawing something falling is just as valuable, okay, as some mathematical explanation. I mean, me putting something 4 times further away from something else is pretty good math, in the sense that you can look at it as like it's a chart. Okay, and charts are made out of mathematical relationships. So this is just more horse shit. And again, I'm explicitly showing you 2 formulas. So I'm explicitly showing you 2 mathematical formulas and saying one mathematical formula I think can be defended as having integrity, and the other one is a complete nonsense, just made up. Okay, 200 years ago by a relativist who was basically trying to explain how things could all hit each other and create a whole bunch of heat, and they could hit each other this way and create less heat. And both things we can account for, because we're going to just say it has 10,000 million joules of energy. So yeah, there was plenty of energy left over. It's all hidden though. It's hidden energy. You just don't get to see it anywhere. It never is realized in the real universe energy. So fuck you. Anyway. Experiments in math to debunk mainstream and validate your alternative. I've done that. I've played their videos. I'll play one again today, and I'll just show out how it's complete nonsense. It doesn't make any sense. No way you can resolve it with the facts. So I've done that. I fulfilled my obligation. Okay. To debunk mainstream and validate your alternative. No one has to pay attention to you. And that's not the argument, whether they have to pay attention. The point is whether a fair, reasonable, intelligent person wants to understand whether they're right or wrong. If you have a counter-argument, I want to hear it. But your counter-arguments aren't counter-arguments to the facts or to the experiments or ever on the subject. They're just fucking insults. Okay, so until you can present some evidence, you're the one with no argument. I mean, I'm begging you to post me to the link. Do you ever do it? No. I give you an analogy and I say, how does this analogy fail? You don't explain anything. You don't say anything. Nothing. Alright. Momentum and kinetic energy are taught in high school. So that's your counter argument. I mean, I'm basically pointing out how, yes, it was taught 200 years ago too. French intellectuals thought this was a right answer. And then people like Voltaire said, that's complete rubbish. Why are you going back to religion? Spooky energy. Why are we inventing a spooky energy? It's quite presumptuous of you to demand that we should waste time educating you. Well, I'm not asking anyone to waste any time. I'm offering $1,700. That's not a small amount of money for somebody to sit there and deal with a 17-minute video and explain how it's wrong. $1,700. Now, yeah, I'm not going to pay you because you obviously aren't even going to give the answer. But, I made a credible offer for somebody to make a credible counter theory. I just tried to post it on a science forum, and all I got in return was insults. I didn't get any arguments about how I'm wrong or how it is wrong. I just got told it was wrong. So again, more horse shit. I asked for links. Show me the experiment you think is explained correctly. How many times can I ask? Show me the video on YouTube that explains the double slit experiment without lying, essentially. Without saying something that's just overtly incorrect. Alright. It is quite presumptuous to demand that we should waste our time educating you. It's like, why are you wasting your time commenting at all then? Okay, if you're not going to make a counter argument that has any teeth at all, you're not making a counter argument that has any teeth at all. You're just making these accusations you can't back up with any facts, and that's it. You're not doing anything and correcting your misunderstanding. So what's my misunderstanding? That you have two formulas that make overt statements about what the energy is, and their numbers aren't even close. I mean, not even close to the same number. And you're telling me they both have some sort of use or value. I'm saying that's impossible. This duality, this formula duality is just as silly as your silly wave particle crapola compromise shit. It's nonsense. It's baby talk. So you keep bringing up high school. Yeah, well, it's baby talk. What they're teaching in high school is obviously horse shit. You think the high school teachers are actually explaining the double slit experiment correctly or honestly? Do you think they're actually describing the actual experiment actually correctly? Do you think so? Honest answer, please. Oh, that's right. You're incapable of that. Okay. On high school level physics and math. So again, it's where I don't remember in high school, frankly, them ever dealing with this fact that you just do the equation a different way and I get a completely different answer, and that's okay. I could respond to your other claim, often repeated by dissidents, that QM has nothing to do with our technology. Yeah, it doesn't have anything to do with it. I grew up when it was invented, shithead. Alright, I read the books that were published at the time it was invented, shithead. And guess what? They weren't talking about quantum mechanics. They weren't talking about superpositions. They weren't talking about any of that stuff. It was a simple enough thing. They realized that certain kinds of matter could operate as switches for electricity. They could pump a little energy in, it would open the door, and a whole bunch of energy could get through. And so that they could get rid of valves and get rid of all this wasteful stuff and make a nice solid state transistor and all that kind of stuff. And all that stuff had nothing to do with fucking theory. As is demonstrated by the historical facts, Einstein had already invented the photoresistor, essentially, right? They had already invented it. The photoelectric effect was the first transistor in a way. I mean, yeah, a crude design, not very efficient, but clearly there was already a huge indication that you could just shine light on something and create current and allow current to flow. So that's just, you couldn't, to save your fucking life, show how any theory has created any of this stuff, because like I said, when you look into every single bit of it, who created it? It was a bunch of engineers just sitting there trying different things. What if we do this? What if we heat it slower? What if we do that? What if we do that? And that's how all this shit was invented, and you're just a piece of shit and a liar to think that it has anything to do with, oh, I knew the special quantum theory and that got me the right answer. And the quantum theory was, oh yeah, light gets diffracted by a slit. Again, what they knew and what they needed to know is far less detailed than any complex theory. But I have already given you more attention than you deserve. Oh, you're so special. Go give somebody else your fucking attention. Your thin-skinned helper. Some more horse shit. You don't make any content. You put up nothing. So I don't get to go over to your fucking channel and harass you with nonsense off-subject horse shit. So why don't you have the guts to actually produce something All right, and then let the little troll show up and ridicule you and poke fun at how big your fucking nose is and how little your little fucking dick is. Anyway, your thin-skinned outbursts and silly threats of banning me are always amusing. Yes, well, just fuck off. You don't amuse me. You're a waste of space and time. Probably a very provable fact. Okay. So again, lots of reading. Anyway, to do. Again, I will again read it, but like I said, I don't think it's exactly getting to the core subject. Are there ways to discern which one of these stupid formulas makes any sense?
Okay, thank you very much for tuning in today.
Yes, okay. I'm pretty excited too.
Today's video, we are going to go over a few quick examples, relatively straightforward examples for calculating.
I think I'll jump ahead of his beg for subscribers.
Here we go.
Okay, here it goes.
Energy of motion. If you are in motion, if an object is in motion, then you have kinetic energy.
The point is, you have to have energy. That is, this stuff has to happen. Something hits with force. Something hits with force. And you keep it. You take the force and you keep it. Gravity gives you something. There's more energy push. Let's just say that's pushing. It's filling your little bucket with stuff, force. And now you have it. You took it from gravity. And now you possess it.
The equation symbol for kinetic energy is KE. I think this is the one you see most often, KE, but you might also see this E like energy kinetic, like you might see EP for energy potential. But I think either kinetic energy, KE, that's what I tend to use, or EK, kinetic energy, kinetic.
Yes, well, let's understand. Potential is seldom, unless you're going to talk about gasoline, a bottle of gasoline or something. There's no point in really talking about potential, because then you're really just talking about how many joules of energy can you cause. Okay. And a liter of gasoline is about 1 million of these. 1 million.
Remember the SI unit, the unit for kinetic energy, potential energy, all energy and work and heat and all that stuff is the joule. James Prescott Joule, Joule.
Yeah, that's really cute too. So let's just understand, right? In my opinion, it would be nice if they just made it something easy to understand. And this is a joule. It really is. This is about it, right? I mean, if I take there's a guy who did a video where he just drops a couple of sticks of butter. So apparently, 4 sticks of butter hitting the ground from a meter. That's a joule.
Abbreviation capital J. This is the equation that we use.
Okay, so let's just understand. This is the equation that completely says mass sucks, velocity is special.
We've seen this before. Kinetic energy is equal to 1/2 times m times v squared. Remember, we'll talk about this again.
Yes, and remember the formula originally for 100 years was mv squared, no half in front of it. So that's how clueless, that's how disconnected this was from any real measurement of this, right? Because 200 years ago, they were saying that there was 4 or 5 or 6 times more of those inside of something than it was actually had. So they were really way off. Not just that, they were a little way exaggerating how much energy there was, because that v squared just goes endlessly. The faster you make something go, and you're getting into preposterously silly big numbers.
But it's just the v squared, not mv squared. It doesn't matter the order in which you do these things in your calculator. Remember, the mass must be in kilograms. M is for the mass. If it's given in grams, you have to convert first to kilograms. And don't forget, the velocity needs to be in meters per second. V velocity.
So 1,000, kilogram, it's got to be 1,000, and that's about a half a pound, right? 1 kilogram equals 2 pounds. Oh, fuck. Something like that. So a kilogram is bigger. 2 pounds fit in there. Yeah. So it's 2 pounds falling a meter? Yeah. Well, that's about a vigorous hand clap.
Velocity meters per second, 1/2 mv squared. You can see all objects, in order to have kinetic energy, they have to have some motion. Sometimes we say velocity, sometimes we say speed, but it's written.
I mean, this is just kind of funny. See, I'm just saying that this is the kind of thing when you're teaching it, you would say to a kid or something, this is the concept of what energy is. Energy is movement. And the movement can be in the big structure, or the movement can be in the little bits. But it has to be movement. Okay, things have to be moving for you to have energy. There has to be some source that can hit something else and make it move. That it's a progression. So if you explode, you have to explode because there's a bunch of movement, like things moving in circles or doing something, and then you're letting them all go, and they're going in directions, and that's when they have momentum. If they're doing circular things, okay, they have momentum in their little tiny circle world, but that circle world doesn't go out to the rest of the universe. The Earth has a lot of momentum, but the momentum isn't getting into the universe, so we don't see it. The universe wouldn't see it.
Technically speaking, you're supposed to say velocity, but here we go with the speed. And here's one of our examples. A car is moving down the street, the road, with a speed of 20 meters per second. If the car, it's kind of a small car, has a mass of 600 kilograms, how much kinetic energy does the car have? Well, here's our equation. It's
right. Now, if we just do the momentum equation, we're going to get 12,000, right? That's going to be the answer. 12,000. The end.
Pretty straightforward. Just going to use this equation the way it is. No rearranging, solving, plug the numbers in. Now I like to write down 0.5 and 1/2. It's the same thing. Mass 600 kilograms. The speed we said was 20 meters per second, and we're going to square the 20 meters per second. Don't forget that, and you will get that's actually 120,000 joules, which means.
Okay, so we know this. It's a huge difference, right? So momentum in this case says 12,000, okay, and the formula says 120,000. All right, so big, giant, huge, monstrous difference, more than 4 times the energy. I mean, that's a ton of energy difference.
Might be better for significant figures if we wrote 1.2 times 10 to the 5 joules. Now, one of the most interesting things is with kinetic energy, of course, is what happens if we double the velocity. So we're going to do twice the velocity. We're going to speed the double. If the speed is doubled, what is going to happen to the kinetic energy? Is it going to go up? Is it going to go down? Or is it going to stay the same or something?
So in the case of momentum, it would just double. So now you have 24,000. Okay, just like in the gravity example, you're just collecting energy, and that's all there is. That's all you have. Yes, you're going faster, but you don't have 4 times more energy.
Anything else? So let's just check it out. We can calculate it really quickly. 0.5, 640, so we double the velocity, double the speed, but remember, it's double the speed squared, so it's like doubling the double. And so the kinetic energy is not going to just be 240,000, because we're doubling and then we're squaring. It's going to be 4 times as much. You can see that this value, 480 times, is 4,000. 4,000 is 4 times this value of 120.
And it's, outrageously, so much more than 24,000. Now we're 20,000. We're 20 times more energy now. It just keeps getting bigger and bigger and bigger. And I would argue that you can't collect any of that. So I can't make an experiment where that's demonstrated. If I take those 2 cars going those speeds, I won't be able to make an experiment where I collect the energy and light a light bulb, for example. If I try to turn it into watts, either one of those cars, and try the most efficient way possible to get all of their wattage out of them, okay, all of the joules out of them through some mechanism, that collects the momentum into some other object which I can convert into electricity or convert into some known temperature, into something. The fact is, I will never be able to collect that 480. I'll only collect 240 from that second object. I'll never get 480. That won't happen. And it's just demonstrating that this formula is wrong. It's overtly saying something that just isn't true. And people should say, reasonable, intelligent people who like the truth and like physics and think this is like the most important subject and all that kind of crap. I mean, they should care that it's true. They won't find a way that they can make it look that way unless they're not doing a clinical experiment, unless they're just doing some stupid thing like how far does it travel down the road? How much distance does it cover? Well, of course, the faster thing covers more distance in the same amount of time, but that has nothing to do with its total energy. How many claps are in it? How many this much movements of this much mass, and that's what it's saying. How much movement of mass does it have? How many of these joule things, these claps, can we get out of it? And I'm overtly accusing you people of just being bullshitters to say there's any reason to believe that 480 is a real number. And there's every reason to believe it's just nonsense. Whether you think of it in the gravity terms, like gravity per second, in 2 seconds time, I can only collect 2 seconds worth of gravity. That's it. It doesn't matter whether something's dropping 4 times as much in the gravity, it's still 2 seconds worth of gravity. And you can't claim that, I doubled that. I got 4 times as much energy. It's only 2 seconds in gravity, but I got 4 times the energy. You can't say that. Then 1 second. Something 1 second only goes this far. Something, goes this far. Farness doesn't matter. How much time was it in the gravity? And its velocity doesn't mean you square its velocity. The velocity and the mass are equally important in terms of defining. It's how much mass is moving how much, and that's always going to be your energy. It has to give equal value to both functions, your mass and your velocity. And if you make them disproportionate like these equations are doing, you're just going to get bizarre and silly answers. So do I really have to go any further? I mean, the points... Is there any other point to make on this subject at this time? I mean, no, I really don't think there is.
Joules. So please don't forget that. Okay, when you double the velocity, you quadruple the kinetic energy. That's why when you're driving a car, if you're going...
So they keep using this example, of how poorly brakes work when you apply more velocity that they have to stop. Just like gravity, they're applying kind of an equal force. They can't apply extra force to stop the extra force. So, of course, something with more velocity is going to be able to go further because it can only, in a certain amount of time, apply a certain amount of force. So unless you make the brake pads bigger and you make the tires bigger proportional to the speed, yes, you'll get results that look like, but look like is not the same as is like.
Really fast, you can hurt yourself because it takes twice as much work. 4 times as much.
So he just said it. Twice as much would be the reasonable way to look at it, and twice as much is a lot. I mean, twice as much. I mean, one hand. Yeah, one hand's really useful, but 2 hands. Oh shit! Yeah, that's great. I mean, it's a whole. Doubling is still a lot. I mean, so yes, of course, if you double your speed, you could expect that things are going to get dramatically rough on you. Imagining this quadrupling, though, does it really seem like it quadruples? I mean, I would argue it doesn't really seem like it quadruples. Double seems like more than satisfactory to explain a car crash. Okay, I don't think you need to quadruple. Double is a lot. I mean, a car going 20 miles an hour and another car going 20 miles an hour, all I have to do is think of the, all I have to do is think of that much energy. You know, that's a lot of energy. Going from one car doing it to two cars doing it. I mean, crashing a 20-mile-an-hour car into something, right, and looking at it and saying, "Woo, that's a lot of damage," and then crashing another 20-mile-an-hour car into it. That's, you know, that's going to make the mess is going to be substantially more messy. It's like asteroid after asteroid or something. You know, dual asteroids. You expect quite a lot of damage. So, you know, but 4 times, come on, no chance.
Much work. Why did I say twice? 4 times as much work to stop, or energy to stop you.
So you said twice because that makes more sense, and that's why you said it.
But be careful, and don't forget, it's not just velocity, but it's velocity squared. It's 4 times as much.
Okay, and just remember that it came from a very suspect origin in the history of physics, a place where everybody was just kind of floating around. There was no, like, physics institution that was, you know, deciding whether the physics was reasonable and testable and all that kind of stuff. It was just sort of like a popular physics and, you know, kind of sloppy origins. Okay, I don't need commercials and whatnot. Alright, so I don't know if I need to go any further. I mean, we've been over it already. The example to give. So the reason why this all gets relevant to relativity, so I've sort of pointed out the start of that argument, that, this squaring crap, and but the real test is just in how momentum is transferred between objects, and that this sort of dictates, I mean, the physical facts sort of dictate that you can't make up this relativity nonsense in the sense of believing that it doesn't matter which object has the actual, let's call it energy, okay, the vector of movement, and which object doesn't. You know, so whether you're hitting something or whether it's hitting you, that's a real question, and it's really in a way answered, because what we do know is that if you had pieces of clay, okay, and you smash them into each other with an equal amount of energy, they'll do one thing. Now, if one of them has more energy, well, then we know they'll do something completely different, in the sense that the clay will deform, okay, both clays will get deformed, but both clays will also move off in this direction. So the two outcomes will be very different, you know, depending on which one is actually moving. So which one actually has the momentum. So you can't do that in the clay experiment and say, well, I could imagine two things, and I could imagine that this one has all of the energy and this one only has none, or this one has all the energy and this one has none, or they have half the energy in opposite directions. Well, that doesn't work because the outcome will be different. So we do know, well, we do have good reason to believe that there is no such thing as this relativity crap, because the energy really is in things. And the real physics problem, you know, I mean, relativity is just taking advantage of the fact that when things are sitting here in space, okay, they have a vector, a way they're moving. And that vector, like the universe, we're all moving in the solar system, we're all moving in the galaxy, we're all moving, and we're sharing that vector. That momentum vector is one we all share. And what we're really talking about is tiny changes that happen relative to us, each other. Okay, but we can't change that original fact that we have a shared vector in the same direction. And so all we can see is slight changes, you know, between us. But the fact is those changes are real. One thing really changes and one thing doesn't change. One thing has the actual change in the vector, more energy in this direction, or less energy and, you know, more energy in this direction, or whatever way you want to look at it. One of them actually has the change in their real, in the universe, total net energy vector. See, at every one moment it's just changing all the time. It's all the time these vectors are changing, and because we're in the same field of force, you know, we're getting the same changes, except the ones between us. So the universe is sending us all the same pressure. You know, we can't have unique circumstances because we're in the same field of energy all the time. But the little bit of stuff happening between us, that can change. And that does change the universe vector of the thing too. But I mean, I'm just saying that we can only see the vectors, you know, that aren't shared. We can only see the ones that we have in dissimilarity. We can't see the ones we have in similarity. So anything we have the same of, we can't see. The only thing we can see are the differences we have between each other. All right, so it's just sort of an argument that there is a real universe, that there is really not moving, and there is moving very close to the speed of light. And those are the differences that you can have in the universe. You can have a very long momentum vector, or you can have no momentum vector. And there's real places in the universe where that happens, and there's real places in the universe where this is happening. And those objects will behave differently depending on which one of those vectors they have, and whether they're imposing or whether they're the receiver. All right. Yeah. All right. So, what might be interesting, I did notice a link on this guy's video to an applied science video. This guy's really smart, so I'm going to watch that video, and he has a Newton's cradle in here. So I'll see, because he's talking about kinetic energy and answering some questions, so we'll see what he's doing with it. But that'll be for next time, and such, and so forth and whatnot. So I think that's enough. Yeah, seems like enough. So till the next time and such. I'm really interested in conversation. People, I just don't know why people can't make videos on the internet. I don't get it. I mean, you would think somebody by this time, this far progressed into this 10 years, and nobody will interact, and all the dissidents won't, because it always gets too hostile between them, because they're selling their theory, you're selling your theory, and you'll just end up talking past each other. So I can understand some of that. But I still don't understand it, in a sense. I'm willing to talk to anybody about their theory as long as they're willing to hear me say how I don't think it's, I think it's shit. But it's amazing just how little capacity to have these arguments there is with anybody. I mean, they're totally non-responsive. It's just, amazing. The internet is totally incapable of producing something like a coherent counter-argument in a forum that is perfect for it. I mean, where you can show it on a chalkboard, where you can explain it. It's just beats the hell out of me. Anyway, so this has been a DraftScience video presentation. Until the next time and such.